Thank you, Nathan, and welcome to everybody to the U.S. VOC regulations with an emphasis on the state of California. My name is Alexis Sumner. I'm a hazardous communications specialist here at ChemADVISOR, and we will get started today. We're really going to look at, first of all, defining what a VOC is at the federal, state, and local level. We'll take a look at all the regulations that impact the VOC, specifically Carb, the California Air Resources Board, and then who's responsible for these specific regulations, how products are regulated, a number of exemptions we'll address at that time, and then demonstrating compliance and the impact on the work that you have to do and your products. What is a VOC? Basic definition of a volatile organic compound is it must be volatile and it must be organic. That seems pretty intuitive, but that's a question that comes up a lot when we actually have to look at the chemical structure of the material that you're using in your product. The EPA expands on that definition a bit to basically include any compound of carbon, and then list a number of exceptions right off the bat, including carbon monoxide, carbon dioxide. And what they're really looking at is these materials react in the atmosphere with sunlight and particularly nitrogen that already are present in the atmosphere. And so they're looking at those that cause this chemical reaction, photochemical reaction, to happen. So these materials react with nitrogen in the presence of sunlight. They form ozone. Ozone at our level is bad as we breathe it in, and definitely contributes to impacting our health and the environment. So these become regulated to control air pollution. So therefore less VOC equals less smog. Smog, many people remember photos or have seen photos of Los Angeles as one city where there's this settling that happens. And smog is smoke, particulates, hydrocarbons, all these compounds that have this chemical reaction occur that you can visually see through air, and we call it air pollution. It's this haze that maybe you can see, and then again that impacts our health and also the environment. So the primary goal of regulating these is to create less smog and therefore less air pollution and toxic chemicals that we are inhaling. And the primary source of smog is actually through motor vehicles. So you'll see a number of occasions where different states have inspections and things along those lines to actually make sure vehicles are working properly and therefore reducing the smog. Looking at a timeline, the first federal rules for air pollution really started in the late 60s. And in 1970, there was a bit of an unrest with the Earth Day demonstrations and things that were going on, and the first air pollution amendments happened. This was also actually the time when the EPA was formed to basically help regulate those air pollution amendments that were put into effect in 1970. We've seen a lot of revisions over the years. 1977, 1990, they looked at acid rain, they looked at some of the new technologies that were being created and how those needed to be regulated that didn't exist previously. And then we kind of fast forward to actually September of last year when California had a final rule that reduced emissions for both consumer products and aerosol coatings. And that rule actually took effect at January of this year. So if you look at how these are constantly being changed and modified, both at the federal and then, as we highlighted here, at the state level. For the U.S. federal You can find these regulations in 40 CFR. The subparts listed here are very specific to the individual products that you would be making. So we have automobile refinish coatings, consumer products, architectural coatings, aerosol coatings, and subpart F deals with emissions from particular vehicles. And what the federal regulations do is set basically a standard, and they allowed states to then actually go above and beyond that standard if they would like. So we'll be talking about, again, California in particular, but in this way they kind of said everyone across the board at least must meet these requirements, and then allowed states to take it a bit further. They also created limits, I should say, for particular products and how those could be used. And they also required states to basically create a way to, get approvals and permits and licensing for manufacturing facilities. And that is kind of how the federal regulations set up for the states to kind of create their own policies and how they would regulate products and facilities within their state. So what is CARB? I've now mentioned California on a number of occasions. CARB stands for California Air Resources Board. This is a part of the California EPA. And really their mission is to promote public health in the state of California, and obviously reducing air pollution, pollutants, and really CARB in and of itself has created a number of rules and gone above and beyond for research. And we can see that here in their objectives, where they really want to be the leader as implementing and enforcing air pollution control rules, regulations, and providing innovative approaches to complying with air pollution rules and regulations. And so, especially here in the United States, if you look at the rules and regulations that are established by CARB, and your products are compliant in the state of California, if you look at then shipping that product to a different state, the likelihood is that you're going to be compliant because California they really are the leader in this, and if you meet the regulations in California, you're going to meet the regulations in other states as well. And that goes into the importance of CARB. They classify volatile organic compounds as carbon-containing compounds, again, with few exceptions, that contribute to that formation of smog and may, in and of itself, be toxic and have hazardous effects on the environment or human health. Again, they are leading specifically the North American market and other states as well in the creation of VOC regulation and product limits. And these are very strict regulations, and they're monitored by local air districts. And if we look here, here we have a map of California, and you can see how it's broken down by the different air districts. I will make one note here at the bottom, the South Coast. That is the area that is where you'll find Los Angeles, and even amongst the state of California, the South Coast Air District in particular has very specific rules, and they are strict about those rules. And so, again, if your products are compliant with South Coast, they will typically be compliant with the rest of California and typically the rest of the United States as well. But again, permits for facilities and also product-specific regulations are each controlled by these specific air districts within the state of California. So I mentioned exemptions earlier. Before we can kind of look at how VOCs are regulated a bit, we kind of have to start off by saying that not everything that's volatile and organic is considered a VOC. So each area, so the US EPA, Carb, for example, as two different governing bodies, they have established a list of exempt compounds. And you can see on the screen here, this is actually the beginning of the list from the US EPA. These specific solvents, although are present and are volatile and organic, are seen not to have a photochemical, do not take part in this photochemical reaction that happens. And so therefore these specific solvents are not seen as VOC and actually are in a sense subtracted out of the equations when we look at how products are regulated. Another exemption is for uses. If products are manufactured only for export from the region. So again, we'll bring up California. If you're manufacturing in California, to not use the product in California, but to send it to a different state, the product limits do not apply to those. So if it's only for export. So again, if you're making a product here in the US to ship to the EU, for that product, you'd have to abide by the EU regulations, and the product limits in the US would not apply because it's for export only. So who's responsible for making sure compliance is met? Primarily it falls on manufacturers, and they're really responsible for obviously product formulation, and each individual product must be compliant, and also the record keeping that goes along with those products, and that falls on the manufacturers. So what they need to keep track of is batches that are made, and maybe if there are any variations in those batches, and also the weight percent and the chemical composition of those products. The weight percent and chemical composition is key to actually determining whether or not your formulation or your product is compliant by the established limits. If you're importing products, again, if you're importing from the EU, as the importer, you are then responsible for making sure that those products are meeting the specific regulations in your area. And again, good record keeping is key to making sure that you have adequate records and can demonstrate this compliance. The end users are responsible for compliance at specific sites. This also works into, if I'm the end user at a manufacturing site, that manufacturing site will have limits based on permit or licensing. As an end user, as a consumer, if the product goes down the supply chain correctly and everyone's maintaining records, I would not have the responsibility as someone using a hairspray bottle or something like that. But the end users, when you're using them in an industrial site, definitely have limitations based on, again, those states' licensing or permit requirements. So how are products regulated? The key to VOC regulations really focuses around product use. And so depending on the actual product and how it's used, and if it's mixed with other items or things like that, that is key to making sure that products are indeed compliant. We'll start off with single stage components. So these are, like I said, the hairspray bottle, or products that are applied as is. Typically you'll see these with consumer products, and the single stage components or products are regulated by the percent of VOC that's present. So solids, water, and the exempt solvents that we talked about earlier are all not included in this total weight percentage. And then you can see from the table below, for example, windshield washer fluid for your cars has a VOC limit of 35% by weight. And so if I was the manufacturer of the windshield washer fluid, I would have to keep records and make sure that my product formulation does not contain any more than this 35% VOC that's present there to be compliant. And this table is from the US EPA. You also have multi-component systems, and multi-component systems are based on an as-applied value, not an as-supplied value. So in the single components, it's actually the VOC weight percent in the container as it is supplied to you. Multi-component systems, this is a major player when we talk about the automobile refinish coatings and coatings in general, is that it's the as applied. So you have multiple components, you mix them together, and then you apply it to a particular substrate. So in that case, these products are regulated as they're applied to the substrate and not as the individual components themselves. So you can see here we have multiple equations, and really you're looking at the VOC. You have to provide both the VOC actual and the VOC regulatory. In this case, we give you the equations for all of them. And then for VOC regulatory low solids, this is a calculation you can do when your solid content is less than 1 pound per gallon of coatings. And this allows for a more accurate value in terms of the VOC that's present. So here we'll look at just pulling out the VOC regulatory. And you'll see in our equation, we break down the different elements that you need to know. And these are what you, as a manufacturer, should be keeping track of when you talk about the different batch-to-batch variations and record keeping. We have up here, we have our coating density in pounds per gallon, is typically how you would see this. We have our total weight volatiles. So this is everything that will evaporate and not stay as part of the product on the substrate. We have our weight of water, and then we have our weight of exempts. And so our total weight minus our water minus our exempts multiplied by our pounds per gallon of coatings. And then down here we have our weight of water, or volume of water, excuse me, and our volume of exempts, and those are taken out of 100. So this equation, just this part, this first fraction, we'll say, would give you a VOC in pounds per gallon. And then this second fraction over here is then your conversion from pounds per gallon to grams per liter. So this is how you would then be able to report your value in both pounds per gallon and grams per liter. As we look at this, you might ask yourself a question of, well, how would I know what are exempt and what are not exempt for solvents? And this is one thing that our LOLLY database has. There's a number of pieces of data in LOLLY, but we can come down here for the U.S. federal government under the Clean Air Act, and we can actually find where it says VOC with negligible photochemical reactivity and the material is present. So in this case, we did a search in LOLLY for acetone, and you'll see right on the LOLLY list that it has negligible photochemical reactivity, and if it's present there, that is a VOC exempt. So the percent acetone in your product would then be listed with your weight exempts and your volume exempt. Again, each of these lists are maintained by the different governing agencies. So this is U.S. federal rule. If we come down here for California, we'll see that down here, at the very bottom here, for U.S. California, VOC exempt from requirement, and then material acetone is exempt from California VOC. So again, if you were doing the calculation, you could say that acetone was exempt both by the U.S. EPA and by the California Air Resources Board in California. Moving on, a different type of material are going to be aerosols. And aerosol coatings and also any aerosols that are created are regulated by a weighted reactivity limit. These weighted reactivity limits are again determined by the coating category. So we can see down here below we have different values, and again, as we noted before, the change in September that came into effect January 2015 changed aerosol coating limits. So that's why you'll see some different dates here. These will be the new value. There's a roll-in of that change. So these are our new values starting in 2017. So manufacturers will have 2 years to become compliant. So here you have the different coating types, and then this weighted reactivity of the product here, and we'll go over how you calculate those. These values are calculated based on the chemicals that are present, and each VOC is then assigned a reactivity factor, and those are added together to, and they must be underneath this product weighted MIR value. Here we have our equations. We have our product weighted MIR value, and again, you take the reactivity factor of the individual component, you multiply by the weight percent for everything that is in there, and that value is what has to meet the limits listed on the previous slide. And those reactivity factors, again, if we come to our LOLI information, we have our same chart here for the US federal and then for California, and these reactivity factors are again found in LOLI. So acetone, if you look here for aerosol coatings, you have your 0.43 grams of ozone per grams of VOC, and then down here we have our maximum incremental reactivity values, and down here you can see that acetone has a value of 0.36, and so the 0.36 and the 0.43, depending on if you were doing it for California or the US EPA, would be your value that would go here multiplied by your weight percent, and then that would contribute to this weighted MIR value. For demonstrating compliance, labels must reflect the appropriate limit. So if you have a consumer product and it's a single component and the limit for that chemical or that product category is 55% VOC, that is actually how you would list it on your labeling. The state of California requires exact values. They require both actual and VOC if you're doing a actual and regulatory if you're doing a multi-component system, and all those should be listed on the individual labels. For aerosols, you actually have to list the category that you're compliant to. So if it's a primer or a clear coat aerosol, you'd actually have to list the individual category that you are that your weighted MIR value is under. And information can be listed on SDS or additional technical documentation, a TDS, for example. And the state of California and the US EPA allow for those kind of extra pieces of data or extra pieces of documentation to list the VOC limits. And the key to this last bullet point, sales and marketing data must support the use to which the product is compliant. And this is really key because products are regulated by product use. So there may be different limits if a product is a glue that is used as a craft glue, a glue that is used for laminate flooring, a glue that's used for plywood. All three of those, although they're a glue or an adhesive, because of their actual product use, have a different VOC limit. And so if I'm a formulator and I'm developing a product for a specific application, and then later sales and marketing say it's also great in this other application, an evaluation would need to be done if the VOC is compliant for this new product use or this new application. And so that's key, not just that you know the values of VOC, but also that when you talk about product use and all your sales and marketing data go out, you're emphasizing the specific product use that you are VOC compliant. Again, there's no requirements that say you must list your VOC on your SDS. A good place to put it would be in Section 9 or Section 15. You can see here I have a screenshot of Section 9 under the physical and chemical properties, and you'll see VOC actual, VOC regulatory, and the different values and units that those are reported in. This is a good place to have it, but again, there's no specific requirement that it must be listed there. Also, with demonstrating compliance, units are really important. Most regulations are written as grams per liter, and I would encourage everyone, as a good rule of thumb, to report your units and report your value in units that meet the regulation. I've seen where a value is reported in a different unit, and maybe when they do the converting to, let's say, if they convert from pounds per gallon to grams per liter, and you have some rounding or decimal place difference, especially if you're very close to your VOC limit, you know, that could make you compliant or not compliant. So it's really important when reporting VOC to look at the unit in which the rule is written in and then report it in that unit. One prime example I always bring up for coatings in the state of Pennsylvania, they actually have a different variation. They have a variation of the VOC calculation, and the units that their regulation are written in is actually pounds per gallon of coating solid. And so it's not just a grams per liter, it's not just a pounds per gallon, there's an actual factor added in for this gallons of coating solid. And so a volume percentage of solid components. And so for the state of Pennsylvania to demonstrate your compliance, you would also need to provide the VOC values with these specific units. The impact, again, labeling is really key to demonstrating compliance. It's really the first thing if an inspector comes in and wants to see products, the label's the first thing that they'll see, and they'll review that first. And it's really important that you list the correct units, the correct limits on the actual label for the product. For North America, we talked about like the multi-component systems. It's actually regulated by the for North America, it must reflect the as supplied values, although for the multi-component systems, you have to do the additional calculation for the as applied. And here's an example of just what you may see if you were having a spray paint that's an enamel. You know, the specific limits, you have to be under 65% by weight, or metallic 80% by weight. And then here for the aerosol cans, the MIR value, you have the maximum value of like 1.4. So this 1.4 would be your product limit. And listing this value on your label would say that the product is under this value. So these are two ways in which you may see it for a couple different products. And again, that's key to really demonstrating compliance and really labeling your cans correctly with the VOC information and MIR information. Keeping track keeping track of shipments. Since VOC regulations are constantly changing, I mentioned the California rule that happened in September, came into compliance into January 1st of 2015. We saw on the chart that there were the 2017 dates. So really, keeping track of ship date is very important. If you ship before the new value is enforced, you can have a different VOC limit than after that date. And so it's really important to keep track of ship dates, and you should be able to match your ship date up with your product information and then show that I'm compliant to whatever limit was in place at that date. And then saleability, when you really look at consumer products, a number of ways in which VOC has been regulated has actually been with the banning of substances in specific products. So again, you could have a product that works great, has a low VOC, but yet there's a chemical in there that if you change usage might actually be restricted in that usage. And so when you look at saleability, especially in the state of California for consumer products, you really have to know the chemicals that are in there and then what restrictions those chemical has per product use. Again, I cannot say this enough, it all boils down to proper documentation. Product use is important and is how all these are regulated, and product use must be consistent. It must be consistent on anything mentioned on the label. It must be consistent with anything mentioned on the safety data sheet. It also must be consistent with the marketing and sales material, any posters, anything that a place might hang up on the wall to advertise. All of those must be consistent for product use. If an inspector comes in and multiple product uses are listed, the VOC of that product, if it can be used in multiple uses, must be lower than that lowest usage limit. So again, if your documentation lists multiple uses, you have to be aware of all of those limits, and your product must be compliant to all of them. For the multi-component system, so this is dealing specifically with coatings, technical data sheets must be supplied, and so that a exact mix ratio can be provided from the manufacturer to the user. So the manufacturer provides a document that says you mix 3 parts of this and 1 part of this, and they basically say that the product, when mixed this way, is compliant with the VOC limits. So providing exact mixing instructions and mix ratios are important for the multi-component systems to demonstrate compliance once they're mixed together, and then it's that as applied value that you're interested in. For aerosol reporting, the US EPA actually requires reporting every 3 years. So Q1 of 2017, companies that manufacture aerosols would have to report on the aerosols they created in 2016, 15, and 2014. So basically, everything from 2014 to 16 would then be reported in the beginning of 2017. And then, obviously, all the new products that come onto the market would have to be reported to the US EPA. California doesn't have a yearly or rotating reporting schedule. Reporting would just have to be done when it's requested of the manufacturer. This reporting would then have formula breakdowns and reactivity factors and weight percentage, and actually show the calculation when we add up that weighted MIR value. So I know that was a lot of information, and I hope it was beneficial. So I will turn it back over to Nathan to see if there are any questions, and thank you very much.